Good morning, everyone. This is Professor Grenfell once again with another video lecture for Math 12 Statistics at RCC. And in this brief video, we're going to discuss Chapter 3, Section 4 on Exploratory Data Analysis, or EDA. It's shorter. It's nicer. Now, in traditional statistics, the data are organized by using frequency distribution, and then we talked about how we could use a histogram or a frequency polygon in order to determine the shape or the nature of this distribution. In exploratory data analysis, we may start off with a stem and leaf plot. As an example of this, we can go back to Chapter 2. And then the interquartile range, the median, and the 5-number summary and the box plot are the primary means at which we will be organizing, summarizing, and presenting the data in order to compare different data sets or make statements about the distribution and its nature, its shape. So one of the quickest ways to capture pretty much all of the information that we're going to be concerned with in EDA is what we call the 5-number summary. The 5 numbers that make up the so-called 5-number summary are as follows. Number 1, the minimum. Sometimes I denote this by lowercase m for minimum. For number 2, that would be the first quartile, Q subscript 1. So that's how I'll always denote that. For this one, the median is Q subscript 2. And I don't really remember if there's an agreed upon MD or something like that. Maybe we could use MD for median. Q3, the third quartile, and I'll use capital M for the maximum value. So the first example that we'll look at is example 3-37, and this is pertaining to the number of meteorites that were found. It says the number of meteorites found in 10 states of the United States is 89, 47, and so on and so forth. They list the data, and so they say to find the 5-number summary and construct a box plot. So the first thing we'll do to find the 5-number summary is we'll find the quartiles, the minimum value, and the maximum value. And in order to do that, we need to rearrange the data in order from lowest up to highest. So we've done that there. And so the first thing that we'll do after we've put it in order is we'll find the exact center of the data set. So here we have to take the average. In order to find Q2, we have to average together 78 plus 89. And so there we get out 83.5, the median, Q subscript 2. Next, we'll consider the lower half of the data set. This will give us Q subscript 1, just looking at the halfway point there. Next, we have to take the median of the upper half of the data set. So here it is. This is Q subscript 3. And then after this, we simply pick out the highest value. So that's capital M is 296. And then the lowest value, we'll call that one lowercase m. So that is 30. Okay, so let's just quickly run through the procedure table for constructing a box plot. Step 1, so this is on page 169 in the book. Step 1, find the 5-number summary for the data. So we did step 1. Step 2, draw a horizontal axis and place the scale on the axis. the scale should start on or below the minimum data value and end on or above the maximum data value. So that's what I've done here. I've drawn the horizontal x-axis going across the bottom, and I have denoted the number values here. Okay, notice the lowest value is 30, so my x-axis includes that value, and notice it includes values all the way up to or just a little bit above the largest value. Okay, step 3 here gets a little bit wordy. It says locate the lowest data value, Q subscript 1, so there that is, the median, Q subscript 3, so right about there, and then the highest data value. Right there. So I've labeled all of those, and then it goes on. Then draw a box whose vertical sides go through Q subscript 1 and Q subscript 3. So we'll draw a vertical line above Q subscript 1, a vertical line above Q subscript 3 there, and then put a top and a bottom, or a bottom and a top, and make it into a box like that. Draw a vertical line through the median, or Q subscript 2. So there. And then finally, draw a line from the minimum value to the left side of the box, and draw a line from the maximum value to the right side of the box. And that is how we would complete our box plot. Now, we have not done this in exactly the same manner or exactly the same detail, but this at least gives us the initial idea that our data might look like this. If we were thinking about making this into a histogram, it looks as if all of the data values, well, I mean, here we didn't go into a huge amount of detail, but here it looks like, well, where is half of the data? Half of the data value is in this range from here to here. The lower 25% to the upper 75%, so that is the middle 50% of the data. And then notice there's not as many out to this side here. There's one lonely value out here. So notice this is a right-skewed distribution. This portion of the box, this is sometimes called a box and whiskers plot. This whisker on the right-hand side is a lot longer than this whisker on the left-hand side, and so that is why we would say this is positively skewed or right-skewed. Okay. Notice we didn't go into a huge amount of detail, but we kind of have our general idea that our distribution somewhat looks something like this. If we were to organize this into a histogram and create that, we'd get something that was along these lines. Okay, so let us take another look. Example 3-38 is pertaining to speeds of roller coasters, and it says the data show the speeds in miles per hour of a sample of wooden roller coasters and a sample of steel roller coasters. Compare the distributions by using box plots. And so what I've done here for the wooden coasters is I've constructed a stem and leaf plot. I have here the stem of 3 and the leaf of 5 to represent this 35. So here the stem is the tens place digit and the leaf is the ones place digit. And that just kind of gives us a way of putting these into numerical order pretty quickly. For the steel roller coasters, if we do the same thing, I've only got a stem of 2, 4, 5, 7, 10, and then 12, because we only go out to the 120s. And then my leaves are, let's see, on the 2 stem, I've got an 8 leaf, right? On the 4 stem here, I've got another 8 as the leaf, right? So that is 48. That's how we would read that. 55, like such, 70, and then we have 100, 102, 106, okay? So that's how we would express that. 100, 102, 106, and then finally 120. And then we'll go ahead and construct the 5-number summary for each of these distributions. So let's start with the min and the max for each of these. It's not too hard. And then for the wooden coasters, I've got them put in order. So I've got 1, 2, 3, 4 values, 5, 6, 7, 8. And so I'm going to take the 4th and the 5th one and average them together. So that gives me a median value of 58. Then I've got the lower half here, these 4, and the upper half. So I'm going to take the median of this set, stopping at 56. So I've got these 2 in the middle, 48 and 50. We'll average those to 49, right? Then looking at this one, I've got the upper half. So it goes from 60, 67, 68, and then to 72. So I'm looking at 67 and 68. Those are the middle 2 values, so we'll average them to 67.5. 5-number summary for set 1. Similarly, 70 is the 4th slowest speed, and 100 is the 5th slowest speed. So those will average to the median value of 85. And then we've got the lower 4 values. Looking at the median of these, we're averaging 48 and 55, so that gives us an average 51.5. And then finally, the upper 4, these 4, 100, 102, 106, and 120, we're going to average 102 and 106 together. Q3 equals 104. All right, and so there we have the box plot for the first set of data, that is the speeds of the wooden roller coasters, and that is how they are distributed. And then what we do from there is we find the minimum value, the first quartile, the median, the third quartile, and the maximum value. We construct a box whose vertical sides are at Q1 and Q3. There's the bottom and the top. Then we draw a vertical line through the median, and then draw lines extending from the sides of the box out to the lowest value and the highest value. So here we can compare the distributions, not only get an idea of where they are centered, so it looks like the speeds of the wooden coasters are less than the speeds of the steel coasters. It looks like the steel coasters are fairly skewed to the left, meaning there's just a couple that are really low speeds. The majority of them are up here that are higher speeds, whereas the wooden coasters are distributed a little bit more uniformly. All right, so that is just a brief glimpse at what we are doing in Chapter 3, Section 4, and how we can get just a graphical sense of the data without having to do horrible, long-winded calculations and make basic comparisons amongst data sets. All right, that's it for this video. Thank you very much, and stay tuned for the next one.